Okay, I think that's live. All right. Hello, everyone, and welcome to my channel. I am going to go ahead and get started and talk about this problem I picked out. It's almost just like the problem I worked out Friday. Very similar process, only entirely different. So I kind of wanted to show how you can solve two completely different problems the same way. And essentially, we're going to do just that. So, remembering this method, we sketched a triangle. We were looking for a distance. If you're looking for the angle, an unknown angle, you can also use these. And I picked a problem with force vectors. So I posted it on my feed on my channel, and I also posted it on my Facebook, but I'll go ahead and just to save, the problem's not going to take me very long, so I'll go ahead and just write it out and stay thorough. And in the meantime, if anybody has a math problem they want to see on the board, feel free to put that in the chat. All right, so this one is dealing with two forces acting on an object. And it says two forces acting with magnitudes of 19 pounds, we'll abbreviate, and 21 pounds simultaneously let's see if I spelled that right. There's an E in there. E-O. U-S. Close enough. On an object. Okay, it says the magnitude of the resultant love that squeaky marker. Force is 35 pounds. And we'll just abbreviate that, 35 pounds. It says find the smallest positive angle between the directions in which the forces act. I'm just going to put between the forces. Okay. So what this is we're going to sketch these force vectors. Remember, when you're sketching them, it's just a directed line segment. Let me back it up a little bit more. So we'll just sketch one that looks approximately 19. And then we'll sketch another one that's 21 pounds. Let's say it's going to go a little bit further than 19. We'll say that's 21. So what we're doing is we're going to make a parallelogram. So I'm going to take this edge and I'm going to put it here. So I'm going to use my ruler, see if we can get it almost. And it doesn't have to be exact. If I was drawing it for some other problem, then I probably would get it exact, but just close enough. And I want it to be about the same length. So let me measure real quick. It looks like it's about 20 inches. So we're just going to draw 20. Here we go. I'm gonna get close. And so, wait a second. Yeah. All right, so I was off. My nerves get me. I'm getting better about the camera, but it's rough. All right, so that's about 19 as well. And according to the theorem, what it says is the resultant is the diagonal, because remember, we're using that parallelogram method. So this one should also be about 21, that equal distance. But all we need is the diagonal, because that is the resultant force. Let's sketch that diagonal in here. We'll just dash it. Here's your resultant force of 35 pounds. And that was also given in the problem. We don't need to have the units on that. It's going to make it more complicated. All right, and so what we're looking for is we're looking for the smallest positive angle between those two forces. So it's this angle right here. We can call it alpha. So what we're going to do is we're going to set up that oblique triangle, and we're going to use the law of cosines. So again, there's more than one way to solve this problem. There's probably multiple. What I'm looking for is that unique way that makes sense to me, that is the fastest. So I want to do the least steps as possible so that I'm not I'm minimizing the room for human error. All right, so what I'm going to do is I'm going to resketch this triangle just like over here, where it just looks cleaner. And I can even draw it upside down if I want. And it doesn't have to be exact. And remember that we're looking for, with oblique, it's not a right triangle, so it really doesn't matter, your legs and your hypotenuse, but your hypotenuse is always going to be the resultant. It's going to be the longest leg. So there's 35. And I like to label it C, the hypotenuse. I don't know why I do that. I just do. And then these are interchangeable. So that one's A. And then this one could be B. And then little a, little b, and then this one will be little c. So remembering that law of cosines here, we've got c squared. Because we're looking for the angle in between these two, we're going to make a list. Let's make a list. C equals 35. Little a equal, we'll say 19. And then we'll say little b equal 21. Okay. And then we do not know big C, okay? That's the one we're looking for, the angle in between. This one right here, alpha. All right, so the law of cosine says the c squared equals a squared plus b squared minus 2 times a times c times the cosine of big C. And I'm going to make the C a little bit bigger just so we can distinguish that it's big C, the angle, and little c. All right, so now I just have to plug in from my list. C is 35, so I'll say 35 squared, and that equals a squared plus b squared minus 2 times a times little c. Oh, I got it wrong. Hang on. I messed that up. That's b. I don't know why I did that. I knew that. 21 times cosine c. That's the part of the entertainment that comes in because I try to be perfect up here and I can't. I'll make something. I will throw a ringer in it every time. So what we're going to do is we're just going to use order of operations, a little bit of algebra, and we're going to solve for cosine c. So get my calculator out. We've got 35 squared. We've got, that's 12, 25. We've got 19 squared. That's 361. And then we've got 21 squared is 441. And then that's minus 2 times 19 times 21. And that I get 798 cosine c. All right. So order of operations, I have got to add these together first. So I've got to basically essentially 798 is a coefficient of this variable cosine c. So these are both the constants, and this is a constant. So we have to combine all those constants, essentially. That's the next step. So we've got 361 plus 441. And I'm getting 802. So 1225 equals 802 minus 798, not 89. 798 cosine of c. All right. So next step in solving for the cosine, we're going to subtract off this 802. So we've got 1225 minus 802. That's 423. That's 0. And then you've got minus 798 cosine c. So one more step in solving for cosine c, we have to divide off this coefficient of negative 798 from both sides. So we're finally getting cosine c equals this. 423 divided by 798. So in order to solve for c now, we'll remember inverses, and then all we have to do is you're basically going to take the inverse of cosine, and it's going to give you c. So you'll say arc cosine of this value, negative 423 over 798 equals c. And then you put it, that's an exact value. Okay. So finally, we have c equals the arc cosine of negative 423 over 798. And that is approximately, you'll plug it in your calculator, inverse cosine, negative 423 divided by 798. And I'm getting approximately 122.0105.351. And so we would just say that the angle alpha is approximately 122 degrees. We'll say approximate. All right, there you go. All right. So hopefully that was not too bad. And see, I told you, it's only 17 minutes. So, and I was late too. So actually, I've only been on stream for, let's see, 15. All right. Well, if there aren't any problems in the chat, then I don't know. Maybe I don't see the point in working another one. We'll just call that good. Looks like my technology's cooperating. That's always good. And yeah, so if you ever need to find the angle between two forces acting on an object, then yeah, this is how you would do it. All right. So happy Monday again. Thank you for watching my video if you watched it. And yeah, I will see you again tomorrow, same time, same place. And yeah, I'll just sign off and say bye for now.